Searching for an element in an array is one of the important problems in computer science. So in this lecture, we're going to talk about linear search, one of the searching techniques. Basically, there are two important searching techniques available. The first one is called as the linear search, and the second one is called as the binary search. In this lecture, we're going to talk about linear search algorithm to search for an element in an array. And in our next lecture, we're going to talk about the binary search. Okay. So first of all, let's try to introduce this problem, the problem of searching in an array. So you are given an array like this. So this is an array. Okay. In this, there are certain elements available in this array. So in this array, when the element of the array is given to you, you're supposed to find out a particular element in this array. The element that you're trying to search is called as the search key or the search element, or it is also simply called as a key value. Okay, you're supposed to search for a key element in this particular array. So let's take an example, case 1, wherein the key is 18. So how do you search for 18, right? If you look at this array, 18 is actually available here. So we say that element is found. So this is a case whenever you found your element. Okay, now let's take different case 2, wherein the key is 65. Now if you look at this array, okay, let's say there are few elements here in between and there is no 65 element available in this array, right? So you don't see any element 65 available in this array, right? So we say that element is not found. Okay, so this is a problem of searching. Given an array and given a key value, you're supposed to find whether that key value is occurring in the array or not. Okay, that's the problem of searching. And finally, your output should be the element is found or the element is not found. Okay, now let's talk about the linear search technique to search for an element in a given array. Linear search is also called as a sequential search. Okay, so in linear search, you are given an array, and from that array you are supposed to find the occurrence of the key element in the array. Now it is called as linear or sequential because we scan through this entire array linearly, and sequentially one by one we'll take out the element, compare with the key element. If it is found, it's okay, we'll stop there. If it is not found, we keep on continuing this process until the element is found or until we reach the end of the array. So this is the idea behind the linear search. Okay, let's take an example of key to be 11. So whenever key is 11, because this is linear search, I'll start my searching from the very beginning index, the first index, that is index 0. I'll search 11 in the index 0. Index 0, the element is 12, so it is not equals to 11, so the element is not found. So now I'll move on to the next index, index 1. So I'll now compare 3 with 11. 3 is not equals to 11, so I'll search with the next element in the sequence, right? I compare 6 with 11. 6 is not equals to 11, it is not found, so I'll search 82 with 11. I'll compare 82 with 11. Now 82 is not 11, so element is still not found. Now I'll search with the element at index 4. Element at index 4, that is A4 in this case. A4 is 11, right? A4 is 11 and my key value is also 11, right? So in this case, I say that the match is found. Now whenever the match is found, I stop here and I did not compare 11, the key value 11, with 1 and 7 and all the elements that is occurring after this 11, right? So I stop my process here. That means I need to break from my process of continuing the comparison, right? So I was planning to do the comparison starting from the first index, that is I equals to 0, to the last index I equals to 6, right? That was my plan. But I stopped this process of comparison at index I equals to 4 because at index I equals to 4, I exactly find my key element, which is equals to 11, right? So this is the entire process of searching in this particular case. Okay, now let's take another case wherein my key value is 62, right? So key value is 62, so I start comparing from the first element. 12 is not equals to 62. Take the second element. 3 is not equals to 62. Continue with the process. 6 is not equals to 62. Continue. 62 is not equals to 82. 62 is not equals to 11. 62 is not equals to 1. 62 is not equals to 7. Now I have reached the end of the array, right? And by scanning all the elements, I could not find the 62 element occurring in my array. So I say that element is not found. So in this case, I had to make more number of comparisons. Here I had to make exactly 7 comparisons, one for 12, one for 3, one for 6, and so on, because there are 7 elements. So I need to make 7 comparisons here, right? So here also I'm actually running a loop starting from I equals to 0 to I equals to 6, right? I equals to 6. But in this case, I had to scan through all the elements starting from I equals to 0 to I equals to 6. But in the case of key being 11, I did not, scan through all the elements in the array. I stopped at index I equals to 4. Okay, so I may have to, stop my loop early on if the element is found. Okay, I hope the concept is clear. So keeping this concept in mind, we'll now write our own logic to implement linear search. Okay, so in a linear search problem, what is given to you? There are two inputs that's given to you. The first one is the array. So let's say that array name is A. Okay, obviously array is having some contents. The values are already there in the array. So this is my array A. In this case, the size of the array n is equals to 7. So there are 7 elements in the array. The elements are 12, 3, 6, 82, 11, 1 and 7. Okay, so this is given to you. And you are also given a key value. This is the value that you are supposed to search in this particular array. Let's say the element that you are supposed to search is key. So you are searching for this element key. So key is an integer value. You are searching this integer value key in this entire array. So what is the logic? As we have already discussed, we'll run a loop starting from I equals to 0 to I equals to 6, because we need to compare the key with each of these elements one by one. One by one I need to make the comparison. So I have to run a loop starting from I equals to 0, which indicates my first element 12, okay, to I equals to 6, which indicates my last element, that is 7. Okay, so first of all, I am assuming that key value is given to me, array is already given to me, so I have to run a loop. So I write a loop for I equals to 0, I less than, what is the last index? Less than n, right? So n is the number of elements. If number of elements are 7, the last index is equals to 6. Okay, so I'll go up to less than 7. Each time I'm incrementing the index by 1. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5 and 5 plus 1 is 6. So each time I increment the index by 1. Okay, so I write I plus plus. So now in this loop, what do I do is I'll have to do the comparison. Now what do I repeat inside the loop is the comparison. What am I comparing is the element at index I. The element at index I is AI. I'm comparing this element with key. So what I do is I'll compare this and check for equality. That is, if the element at index I is equals to the key element, that means the element is found, right? So in this case, I'll just write printf element is found. Once the key element is found, my job is done. So I'll have to stop this entire loop. So I'll just write break here, because now I've found my element. Okay, so element is found. Now the element found case is done. Now how do I write a case in which the element is actually not found in the list, okay, or in the array? Now let's say the key element that I'm searching for is 17. Now if you see 17 element is not there in this array, right? This is the not found case. How does it work? Now if element is not found, what happens is I compare 17 with all these elements, right? Still the element is not found. Let's try to see this. Whenever key is 17 and I is 6, it will try to compare, right? I is 6 here, key is 17. It will do the comparison AI, that is A6. What is A6? A6 is 7. 7 is equals to key, which is 17. This is false. So it will come outside of if, right? And then it will go and increment the value of I. Now I becomes 7. Now whenever I becomes 7, it will go and do the comparison now. 7 is less than, n is 7. This is false. So now this becomes false. So whenever this becomes false, it will come outside of the loop, right? So this becomes false, it will come outside of the loop. So there are two possibilities to come out of the loop. One possibility is whenever it encounters the break statement, it will come outside of the loop. Now this is the case whenever the key element is found, right? And there's one more case, whenever the condition of the loop becomes false, it will come out of the loop. Now this case, whenever the condition of loop becomes false, it comes out, is the case of the element is not found, right? So this is the case whenever I equals to 7, that means 7 is nothing but n, right? So whenever I equals to n outside of the loop, that means I have compared my element, the key element, with all the elements in the array. Still the element is not found, right? So whenever I equals to n, I can say that element is not found in the list. Okay, so I'll write that here as a code. So after the loop, I'll write if somehow my index I happens to be equals to n, that means I've compared with all the elements, the element is not found, the key element is not found. So I'll just write printf element not found. So this is the entire logic to check if the given element key is there in the array A or not, right? There are two cases. One is the case of element found and one is the case of element not found. Now let's try to put this entire thing as a computer program. So this program linearsearch.c is already created. In this program, we have defined the array A, which can have the maximum capacity of 10 elements. N is the size of the array, I is the index for running the loop, and key is my key element. So input of the array is done. So array size I've taken here, and the entire array I've scanned it inside the loop. So entire array elements are scanned from the user, right? And finally I'm also scanning the key value. So I'm assuming that key value is already there with me. The user is going to provide me the key value. Array is already scanned from the user. Now we are going to do the processing. This is where we actually perform the linear search. Now, as we have already discussed, what we do here is we have to write a loop. Okay, so starting from I equals to 0 to I less than n, I plus plus. This is the loop that will help me to scan through all the elements in the array. Okay, so this loop will scan through all the elements in the array. So I'll write it down here as a comment. At each iteration of this loop, I'll have the access of the element that is called as AI. AI is the element that I'm having hold of. Okay, so what I'll do is I'll compare my key value with the element at index I, right? So this is the comparison. If it is actually matching, that means if this key value is equals to the element at index I, that means I'm guaranteed that my key element is found, that is the element is found. So I'll write printf key element is found. Okay, once the element is found, what do I do is I'll have to break, because I did not continue. Once the element is found, I'll stop my entire loop here itself. Okay, so it'll come outside of the loop. Okay, so break will take me out of the loop, so I can be here outside of the loop whenever I actually find the element. So in that case, if the element is found, the value of I should always be less than n, because I've already found the element and then I'm breaking from the loop. Okay, this is the case of element found. But if the element is not found, I'll also still be outside of the loop if element is not found. Okay, so in that case, I've scanned through all the elements in the array. So in that case, I would be exactly equals to n. So whenever I is exactly equals to n, that means that I've scanned through all the elements in the array, still the element is not found. So I'll put an if case here. If I equals to n, that means the element is not found. Okay, so I'll write printf element not found. I can do one more thing. Whenever the key element is found, I can also print the index of the key element, right? So I can write key element is found at index. So what is the index? Let's say it is found at index %d. So in this case, the index is nothing but I. I is the index where the key element is found. Okay, so let's try to compile this code and see if it works fine. Okay, so compilation is successful. Let's try to run this. So enter the size of the array. So let me give 5. Let me give some values: 12, 34, 23, 9, and 19. Okay, so these are the elements. I'd like to search for 19. So it says that key element is found at index 4. So this is working fine. Okay, let me try with one more input. Let's say the number of elements are 5. Okay, 5 elements are 12, 76, 45, 34, and 90. And let me search for the element 99, which is actually not available. Let's see if it works or not. So whenever I give 99 as the input, it says that element is not found. Okay, I hope in this lecture you have learned how linear search actually works and how you can implement linear search. That's all in this lecture. In our next lecture, we are going to learn about binary search. Stay tuned.